Haloalkane and Haloarenes. Haloalkanes, as I told you, that you have an alkane, you have an alkyl group, and on it you put a halogen, right? For example, CH3Br, okay, CH3, CH2Br, or I you can put. Not only, you have four type of common halogens, right, Anushka, Laya? And what are those four types of Abdullah? What are those four types of halogens? Tell me quickly. FCl, Br, and I. Okay. Is it clear, Praneem? So you can connect F, that is fluoroalkane. Okay. And if you connect Br, that is bromoalkane. Okay. And alkane can be methyl, ethyl, depending upon the number of carbon atom that we will see. And haloarenes means you have a benzene ring, which is also known as aromatic ring. You have a benzene ring. Actually, this is a short way of writing. So benzene has 6 hydrogens all around it, and you remove any one of the hydrogen and you put Cl. So that is chlorobenzene. Okay, and you can have bromobenzene also, or fluorobenzene also, or in short you can write it as PH. This benzene ring is the phenyl ring, Taneem. Okay, it is also represented by the letter PH. Okay, and PH I. This is iodobenzene. Okay, clear. But if you want to write in terms of formula, this is the structure. Actually, the structure which we are writing here is bond line structure. So there we don't show any carbon or hydrogen. Just we put lines for the carbon-carbon bonds. Okay. So this means what? This means you have a carbon, 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 carbon. You have 6 carbon atom, because benzene is a cyclic ring having 6 carbon atom, and there are alternate double and single bonds. Okay, there are hydrogen atoms. Okay, so all of these benzene has the same structure, but instead of writing this detailed structure, which takes a lot of time, what I did, I use that bond line structure. Okay, this is known as bond line structure. Okay, so this one and this one are same. Okay, benzene, the formula is C6H6. Okay, the formula is C6H6. So what I did, if I want to connect iodine, what I need to do, I need to remove one hydrogen, because always keep in mind that the carbon can make maximum of 4 bonds. Okay, total 4 bonds you need to make, not more than 4. Okay, or not less than 4. If the bonds are more than or less than 4, then you will have a charge. Okay, so for neutral carbon you will have 4 bonds. So this is iodobenzene, and you can write it also as so benzene was the formula is C6H6. You might have studied at many places. Okay, and if I want to make it iodobenzene, okay, I need to remove one hydrogen and I need to put one iodine. Is it clear to everyone? Raneem, Abdullah?
Yes.
Laya, Anushka, okay. So this is the general way, general representation. Okay, and they can be further classified into primary, secondary, or tertiary. Okay, primary, secondary means carbon. Primary carbon is the carbon which is connected to one carbon. Okay, so if your bromine is connected to a carbon which is connected only one carbon, that is primary. Okay, so likewise we can differentiate. Okay, and we will do it as we move subsequently in the chapter. Okay.
Sir, for chlorine also the same, right? Remove one carbon, right? Sorry, remove one hydrogen, right? For chlorine also.
For chlorine, yeah. For example, yeah, this is which
C6H5, then connect chlorine. Like that,
yeah,
right?
yeah, 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 exactly. C6H5, yeah, you can write it in a This is actually condensed structural formula. Okay, C6H5Cl for benzene, and for ethyl chloride also you can write it C2H5Cl. Yeah, for benzene also you can write chlorobenzene. That will be chlorobenzene. Yeah, either you can write the number of atoms.
Which way is
Yeah,
better?
actually it depends. But you are not going to write this one. That is for sure. You can use any of these. Okay, because this, if you write this, it will take a lot of time and it will occupy a lot of space. You don't have that much time. Okay, so you can check your book also, which I am having right now, and you can see wherever it is represented. So everywhere you have either the bond line representation, okay, clear, or these condensed structural formulas. So benzene, you can see how it is written, okay, everywhere, right? Clear? So look here. So not only you have one bromine, you can have two bromine, or one bromine or one chlorine. So all are aromatic halides. Okay. So so what is the formula for this? Can any one of you tell me quickly? Abdullah, Laya, Anushka, what is the formula for this one? So benzene is C6H6. Okay. So C6H, you need to remove two hydrogen, 4 and Br. But if you write the formula, the disadvantage is you will not know where the two bromine are connected. Okay, are the two bromine connected on the adjacent carbon atom, or are they connected on the first and third carbon atom, or first or second? Okay, so you need to write something else also. So these two positions, these two adjacent positions are known as ortho. Okay, and these positions are, you fix one position, okay, and the adjacent positions on the benzene are known as ortho, and next to adjacent are known as meta. This is a common way of naming, and this is para. Okay, ortho, meta, and para. So in common name you can write this is meta. Okay, M you can write, so M represent meta, means the ortho means adjacent positions, and meta means after the adjacent. Okay, but in IUPAC, so this is meta dibromobenzene, that is a name. Okay, you can see, but in this is the common name, ortho, meta, para. Okay, ortho position will be this one, O. This will be meta position, right? Is it clear to everyone? And this will be para position. Okay, so that ortho, meta, and para will come only if you have two groups connected. Is it clear to everyone? For one group you can connect it anywhere because all six are same. Anushka, Laya, is it clear?
Yes, sir.
Okay. Abdullah and Raneem, is it clear to everyone?
Yes.
Okay, good. So yeah, so two bromine, but in IUPAC name you don't say ortho, meta, para. That is just a common way of naming. So you use the numbers 1, 2, 3. So 1, 3 dibromobenzene. Okay, is it clear? So this is you can go through, all of you can go through this. Vinylic is the carbon which is directly, the doubly bonded carbon is vinylic carbon. Okay, and the carbon atom which is next to doubly bonded, so this is vinylic carbon, and these are vinylic halides, as you can see over here. And if you have a carbon atom which is next to doubly bonded carbon, like this one, this CH2 which I am writing now, okay, this is allylic carbon. These are just common way of naming. Okay, this is vinylic and this is allylic. Allylic is not given, I think, in this one. They have given only two. Allylic is not given. You can note it down. Okay, allylic. Yeah, it is given over here. Allylic. This is the allylic carbon. This is the allylic carbon. Why? Because it is not the doubly bonded carbon, but it is adjacent to the doubly bonded carbon. These two carbon are vinylic. I'm writing V, and this is allylic. I'm writing A. Clear? So yeah, you can go through the common names. You can go through the IUPAC name. You can go through the types. Okay, very simple, and we will do it as we proceed ahead. So let me start with the preparation. Okay, preparation of alkyl halides. So how do you prepare alkyl halides? So from alkanes, preparation can be done from various compounds. You can have alkanes, you can have alkenes. So let me start with the preparation of alkyl halides. So what is the way to prepare? From alkanes. So I need to hear one word. What is that word? Abdullah, Ranim, tell me. What is that word? What that word is? How can you prepare? I need to hear one word that can tell me that by you doing that process, that is the name, that word is the name of the process. You can get alkyl halides, okay, from alkanes. Yeah. So what is that word? That word is Anushka, Laya, tell me.
Hydrogenation.
Pardon? By? Yeah, Rani.
Hydrogenation.
Hydrogenation is attaching hydrogen. Okay. So you will use, you are putting halide. Okay. So you are going to use the word halogenation. Because you are doing the halogenation. But Anushka and Laya, this halogenation the reaction requires energy. Okay. It can't happen on its own. So how you are putting the energy? With the help of the light. Okay. UV light or sunlight. So you are doing the halogenation of alkanes. You require some energy, right, Anushka? Laya?
Yes, sir.
And you give that energy in the form of light, and that's why the reaction is known as photohalogenation. Okay. Is the name clear? Photon means the particles of light. Okay. So let's see how it happens. So you take methane. Methane is the smallest alkane. Okay. And you take chlorine. Okay. And you take some light. Sometimes it is written as H nu. H nu means the energy. It is the energy of the photon of light. Okay. H is the Planck's constant and nu is the frequency. Okay. That you might have studied in your class 11th atomic structure. Okay. Sometimes it is written like this, or sometimes it is written as UV light. Because actually you require light of more energy so that it can break the bond of chlorine, and that's how the reaction will start. Okay. Or sometimes it is written as sunlight. Okay. Any one of those you can write. Okay. So what you need to do, select one H, select one chlorine, remove them and join the remaining portions. So CH3Cl plus HCl. Okay. Is it clear to everyone? The trick
Yes, sir.
is, yeah, very good. So trick is do like this. HCl, put it separate, connect CH3 and Cl. Okay. And this is the monochloro derivative. Derivative means which is derived. Okay. So monochloro derivative of whom? Of methane. Okay, it is the monochloro derivative of methane, and its IUPAC name is chloromethane. You don't have to put 1, 2, or 3 because there is only one carbon. Clear? Okay, that is chloromethane and HCl you get. This is a trick. But if you take more number of chlorine, more moles of chlorine, you can have dichloro derivative also, trichloro derivative also. Okay. So suppose if you react it with Cl2 and light further, okay, one more time, if you get the product, you can do this reaction one more time. So you can remove the hydrogen and you can put 2 Cl atoms. Okay. So this is the dichloro derivative of methane, because I have put 2 chlorine in place of 2 hydrogen. Okay. And the IUPAC name is 1,1-dichloromethane. Okay. If you can react it further, Cl2H nu means you are doing halogenation, chlorination one more time. You can have this Cl3, and this is a very famous compound. What is the name of this common name? Yeah, guys, come on, tell me. What is the common name for CHCl3? Anushka, tell me. Common name. Laya, Anushka. Yeah, Anushka. I didn't hear your voice.
No, sir. I'm not
What is
sure.
the common? Yeah, what is the common name for this? Chloroform. Okay, where it is used, Laya? Yeah, Anushka. Where it is used?
Anesthesia.
Yeah, Raneem, it is used as an anesthetic, a sweet smelling liquid which is used. Sometimes they don't tell you that we are using chloroform. They actually indirectly tell you a sweet smelling liquid which is used as an anesthetic means it is chloroform. Okay. So this is the common name. And what is the IUPAC name? Abdullah? One trichloro methane. Okay. And you can do it one more time. The chlorination, you can do it one more time. Then that is actually the last time which you can do, because you were having 4 hydrogen and you can, that's why you can do only 4 times. Okay. And this is known as carbon tetrachloride. Okay, that is a common name. Okay. It is also known as pyrene, which is a fire extinguisher. Okay. It is used as a solvent in many organic reactions. Okay. And the IUPAC name is 1,1,1 tetrachloromethane. Okay. That's all. So suppose if someone say you, I hope everybody is writing. Okay, keep writing. Okay, you have all the facilities. Okay, you can take the screenshot and all. All of you know it in a much better way as compared to me. Okay, so that for that I'm sure, but actually you need to write it with your hand. Okay, because at the last moment when there is a scarcity of time, when we feel nervous, our handwritten notes are very helpful. Okay, and they provide comfort. Okay, so keep writing. Okay, that is the best thing. Okay, is it clear? So carbon tetrachloride, I hope it is clear, and I hope all of you are writing. So yeah, very good. So suppose if I take ethane, and if I take ethane, that is C2H6, and if I do its chlorination, how many different monochloro derivative we can get? How many different monochloro derivative of, if nothing is said, you will write the monochloro derivative. Number of monochloro derivative which you can get, different number of different monochloro derivative. Yeah. Yeah, guys, come on, tell me. So ethane is having only 2 carbon. So do we have 2 monochloro derivative layer? Or will it be just one?
So it will be just one, right?
Yeah, it will be just one. Okay. Or someone may say that we can connect the chlorine on either on this carbon or that carbon, but it is going to be same because this carbon or that carbon, they are both methyl and they are same interchangeable. So if you have interchangeable carbon groups, they are same actually. So the numbering is done from the end, which gives lowest number to the substituent or the side chain. So this is 1 chloroethane, and this is also 1 chloroethane. Okay, this is not 2. You will not number it in this way. Ranim, Abdullah, is it clear? This is wrong. You need to start the numbering so that your side chain or the group gets the lowest number. Okay, so both are same. So only one monochloro derivative you can get. But if someone asks you that how many how many dichloro derivative can form with chlorination of ethane? Total number of dichloro derivatives of ethane. Yeah. Praneem and Abdullah, Anushka and Laya, tell me quickly. Dichloro derivative of ethane, how many you can get? And what are their IUPAC names? Yeah, come on, quickly tell me. So you need to put 2 Cl atoms, okay, on ethane. Where you can put, what are the different possibilities? Tell me. Abdullah, Ranim, tell me quickly. Anushka, Laya. Yeah. How many dichloro derivatives? Read it very carefully. It means you are connecting 2 chlorine atoms. Okay. On either you can connect them on the 1 carbon, either you can connect both of them can be placed on 1 carbon atom only. Okay. So this is one of the way. CH. Okay. Cl and Cl. Okay. And the another way could be on adjacent carbon atom. Okay. And this is 1 dichloroethane. And the second one is 1,2 dichloroethane. Is it clear? Is it clear to all of you? Right?
Sir, could you explain this again?
Yeah, this one. So there are two carbon atoms. Okay. So if the question is asking, you need to put two chlorine atom. So what are the options available with you? Either you can put both the chlorine atom on the same carbon, like this one, or you can put both the chlorine atom on the adjacent carbon, like this one. Okay. Because the molecule was having only two carbon atoms, so these two are the only possibilities. These two are the only possible ways. Or someone may call it, okay, I can create a third way also, but that is not going to be a new way. That is going to be the same as the first method molecule. Is it a different one or both are same? They are same. Someone may call it, okay, this is a new molecule. Someone may call it, someone may argue that, oh, this is a new molecule. This is 2,2-dichloroethane. No, this numbering is wrong, because we how we do the numbering of the main chain, we do the numbering such that the chlorine atoms or the groups or the side chain get the lowest number. So this is not the correct way of numbering, because the Cl atom are on the left hand side, so you need to do the numbering from the left hand side. Okay, so 1,1-dichloroethane. Is it clear? That's how the numbering. So both are same.
Yes, sir.
Yeah, right, they are not different. And what type of halide is this? Laya, what type of halide is this one? There was a name, Raneem Abdullah.
Yes.
Yes. Yeah, this name is what? Yeah. This is gem or geminal. Okay. Geminal means two same group connected to same atom, carbon atom. And two chlorine connected to same. And this one is, okay, the next one is vicinal. Okay, so sometimes in short it is written as VIC. Okay. Geminal is written as GEM, gem. So in short, someone may call it gem dichloride, means two chlorine connected to same atom, carbon atom. Or someone may call vicinal dichloride, means two chlorine atom connected on adjacent carbon atoms. Is it clear? So that's how you need to do. Okay, clear. So I hope this is clear. Any doubt, you can stop me any number of times. Okay, don't hesitate. And no doubt is actually too small. So you can ask me any doubt, any number of times. I will be really happy to answer your doubts. Okay, so what about propane? So suppose if someone just write Cl2 and light or sunlight, which dichloro derivative, which chloro derivative should I make? Mono, di, or tri, or tetra? If nothing is mentioned, you are going to put only one chlorine. Okay. So one chlorine means monochloro derivative, and how many monochloro derivative you can get? Yeah. Tell me quickly.
Sir, one.
One or two or three. There are three carbon atoms. Abdullah, Raneem, there are three carbon atoms. Yeah. How many, Anushka?
Sir, if there are then three carbon atoms, then I guess then we can get three monochloro.
Yeah, three carbon atom, but we need to look how many different carbon atoms are. Okay. So this one and this one are same. So first what I do the planning in rough, as a rough work. Okay, this is the rough work. Why they are same? because this is methyl, that one is also methyl, and if you turn them like this, they are both become same, and they're indistinguishable from one another. Okay, clear? So so I can select any one of them. Okay. So suppose if I select both of them, because both are CH3 only, then it is not going to give me a new result. So let's see whether it is giving. So I removed one hydrogen and I put Cl here. I removed one hydrogen and I put Cl on the left. Methyl. So are both of them different or same? I can number them 1, 2, and 3. In this case, I need to number them 1, 2, and 3. I started the numbering from the end, which gives lower number to the side chain. Abdullah and Ranim, is it clear or not? Laya,
Yes, sir.
okay. So this is also one chloropropane and this is also one chloropropane. Someone may argue that, oh, this is 3 chloropropane because you have connected the chlorine on third carbon atom. No, my dear students, you will start the numbering from that carbon itself, okay? Because you need to give the lowest number to the carbon atom bearing the locant. Okay, locant means a substituent or the location, okay, of the substituent. So that is called lowest locant rule. Okay, so this is only one. They are not two different, only one. But there is one more carbon atom. Total 3 carbon atoms were there. We covered 2 carbon. The first and the last are same because they are symmetrical. Okay, and there is one more carbon atom in the middle. So I do the rough work. I put same type of marks. For example, underlined it in same on same type of atoms, and I put different mark on different type of carbon atom just to have a whole picture in my mind, so I can write the answer very quickly. Okay, before writing it, I just do the planning. Okay, that saves my time. So you should also do it. Okay, so this is same, and the name is IUPAC name is 1-chloropropane. The other one is this is CH3. Okay, and but this, you know, that it is not same as that of first molecule. It is different because the Cl is connected to the middle carbon. So this is 2-chloropropane. Okay, this is an example of secondary chloride because the carbon atom on which the Cl is connected is 2 degree. Okay, why it is called 2 degree? Because it is connected to 2 carbon atom. Okay, this is 1 degree. Okay, 1 degree carbon. Why I'm calling it 1 degree? Because on the carbon atom on which chlorine is present is connected only to 1 carbon atom. Okay, and there is another name also. So if all the carbon atom are one after another, okay, for example, in this one, the Cl is there, then all the carbon are one after another. This is normal. This is also common name. This is common name. Normal chain. Normal chain means you have all the carbon atom one after another. On one side, you have a group Cl, and rest all the carbon atom are on other side. Okay, there is no branching, just in a, they are one after another. Okay, so this is called normal profile. These are the common names, but they are very common. They are so common that you need to know them. Okay, and this one is isopropyl chloride. What do you mean by iso? Normal chain means, so if someone call you normal chain, normal profile means all the carbon are on the one after another. There is no branching. And if there is a branching, and if you have, suppose this one, okay, this and this are same. Is it clear? They may appear different to you, but they are actually same. Why they are same? You will say, okay, this methyl is like this and this methyl is like this, but don't have to worry. You need to do the numbering to know. and the numbering is done from one end to another end. Okay, so if you do the numbering, the longest chain is still have 3 carbon atoms. Okay, so it is propane and 2 chloropropane. Same. It is just like that if I keep my hand like this or like this. Okay, so I say I have 2 type of left hand. Okay, no, that is not the case. Okay, this is one hand, and I say, okay, I have 2 left hands. Okay, this is my left hand. Okay, so this is one, this is another. Am I right? No. Okay, so same way, this is propyl chloride, 2 propyl chloride only. Okay, in one way, in one it is written like this and the Cl is in the middle, but this is not normal propyl chloride, because if you look at the carbon on which the Cl is connected, and from that carbon, not all the carbon are on the one side, they are on 2 sides, one methyl here, one methyl there. So this is not a normal chain. In normal chain, if you select the carbon which is having chlorine, bromine, or OH, or any other group, or amine also, NH2 group also, all the carbon will be on the one side and there will be no branching. Here you have branching, and the which branch is known as iso. In that, my dear students, if you have one CH3 just coming out from the second carbon, that is called iso. Okay, iso. This is common name, right? And this is IUPAC name. So IUPAC name are actually easy because they have uniform set of rules. But in common name, the set of rules may fluctuate sometimes. Okay, so you need to be very careful with the common name. Okay, is it clear? Abdullah, Raneem, any doubt in this till now?
Sir,
Yeah.
sir, I'm still, there's still a bit confusion in the sense like, how can we decide how many dichloro or mono or tri are present? I still didn't understand that.
You need to look at different type of carbon atoms. If you have same carbon atom, okay, 2 times, same carbon atom twice, that doesn't mean you will have 2 different products. You need to look at how many different carbon atoms are there. Okay, so let me ask you one more question, and that will make all your doubts clear. Okay,
Yes, sir.
so for example, let's take another alkane which is of 4 carbon atom, and that is butane. This is butane. Okay, and someone may write it like this also, but don't get confused. Someone may try to confuse you by writing it like this. Okay, so you need to check how many carbon atom are there in the longest continuous chain, and they are 4, so it is same. Okay, it is not a new molecule. So if I do the bromination in the presence of sun, I take the bromine, I take sunlight or UV light, and I mix them together and I put them together and I heat them. How many different mono-bromo compounds will form from this alkane? Yeah, just try it. Raneem, Abdullah, Laya. How many different mono-bromo compounds will form? So what can we do, Anushka?
Sir, this is the place where I'm getting confused. Like,
Yeah, okay. So try it one by one. No problem. This is actually your doubt is genuine. Okay, this is the place where everybody get confused first time. So no problem. This is quite normal. Okay, so don't worry about it. This is quite normal. So let's do one by one. So where can we put? Let's start with that. So where can we put bromine? Where can we remove hydrogen and put bromine? So I number the carbon atom for you. 1, 2, 3, and 4. Okay. So where can I put the bromine? Where can I replace the hydrogen by bromine? Tell me. One
the
by one
first-
we can try. Yeah. Which one?
the first carbon atom.
Yeah, the first carbon atom. Okay. So if I remove one hydrogen, I need to put bromine. Okay, good. This is one product. Now, what else can form? Where else I can put the bromine?
In the fourth one, the fourth carbon atom.
Yeah, we can proceed one by one. Okay, I will put it on the 4th. Yeah, good. Okay, so are these two same or different?
Sir, same.
They are same. Why they are same?
Because in both the cases, the bromine is attached to the first carbon.
Yeah, it is attached. It is not attached to the 4th. Okay. So because while giving the number to the bromine, I will start by numbering from the carbon atom such that the carbon atom having the bromine atom get the lowest number. Abdullah, is it clear? And in this case, I will do it in this way.
Yes.
Okay, very good. So these are, so this is one bromo butane and that one is also one bromo. You can't have 4 bromo butane. Okay, this is not the right way of numbering. This is wrong. This is correct. So both are same. Right. Any other place where you can put the bromine? You have put bromine on one first carbon atom. You have put it on the 4th carbon atom. Yeah.
In the second carbon atom as well.
Yeah, second carbon atom. Yeah. And this is 2-bromobutane, right?
Yes, sir.
And what and where else we can put?
Second carbon atom.
Second we have already put. Third. So are these two different or same?
Sir, same.
They are same. Because if you are, though we have chosen the 3rd carbon atom from the left hand side, but while writing the name, you need to do the numbering from the side which gives lowest number to the carbon atom having the group. Okay, so this numbering 1, 2, 3, and 4 is not correct because this is giving 3. Locant as 3. On the other hand, this numbering is correct. 1, 2, 3, and 4. This is correct because it is giving bromine to lower number, second number to the bromine if you do the numbering from this side, right hand side. So this is also 2-bromobutane. So total, how many different products, how many different mono-bromo derivatives you got after doing the bromination of butane? Though there were 4 carbon, and just for our satisfaction, we wrote 4 different products. But actually, how many were distinct?
Sir, 2.
Yeah, only 2. Okay, is it clear to all of you?
Yes, sir.
Raneem, Abdullah, Anushka, Laya.
Yes, sir.
Yes,
Okay,
sir.
that's how we do. So what I do, instead of writing all these products, because it take time. So what I do in rough work, okay, not in the fair, because your marks may get deducted. What I do, I write it like this. Okay, short trick. Okay, so this side and this side are same. Okay, because both are CH3, and this one and this one are same. So how many different carbon atoms are there? Though there are 4 carbon atoms, because from the middle onwards, the structure start repeating. So you have 2 different types of carbon. So 2 different types of compounds you can get. You can put bromine either on any of the CH3 or any of the CH2. That is a short trick. Okay.
Yes, sir.
So yeah. So this is given in the NCERT also, and where it is given, actually, it is given bit ahead, but it need to be given actually free radical halogenation. You can see. Okay, 10.4.2, and they are showing UV light Cl2. Okay, they are making different products. Okay, so let's do one more question then, and this is actually a very good question. It is there in all the books. Okay, and this is the reverse question. Okay, so till now, what I did, I gave you the alkane, and I asked you how many mono halo derivatives you can get. Okay, but in reverse question, what they will give, they will give the number of mono chloro or mono bromo derivatives, and you need to tell me which alkane I have taken. Okay, so this is a reverse question. It is little bit you need to think, work little bit more. Okay, so let's try it, and don't worry if it goes wrong. Okay, first time it can go wrong, not a problem, it's but natural. Okay, so let's start with the question. So I have taken a pentane. So pentane is actually an alkane which is having 5 carbon atom. So its formula is C5H12, because CnH2n plus 2. Okay, so pentane. But I have not yet told which pentane I have taken. Pentane have different isomers. Okay, because there are 5 carbon atoms. And you can have a chain of 5 carbon atom. You can put chain of 4 carbon atom, 1 carbon atom you can put as a branch, or you can have chain of 3 carbon atom. You can put 2 carbon atom as a branch. Okay, that is the formula is going to remain same, and such type of compounds are known as isomers. Isomers are the compounds having same formula but different structures. So pentane is having 3 isomers, P, Q, and R. Okay, clear? This P, isomer P, if you do the chlorination, it gives only single monochloro-derivative. Okay, isomer P. Isomer Q, upon doing chlorination, they have same formula because isomers have different structure but same formula. Isomer Q, this gives single isomer Q gives 3 monochloro derivatives. Okay, and isomer R upon doing chlorination gives 4 monochloro derivatives. So you need to tell me what is the structure of P, Q, and R. This is your NCERT question. Okay. It is there in the textbook also, but where they have given, let me show you this one. Can everybody see it?
Yes, sir.
Okay. Yeah. So let's try this question. Abdullah, I hope you can see the question. So first of all, let's try how many different pentanes we can make. Okay, pentane is actually alkane having 5 carbon atoms. Okay, so the first and the easiest way so types of pentane. So 5 carbon atom, they will all have same formula C5H12, but their structure will be different. So first way to draw the structure is put the 5 carbon atom in a normal way. Okay, that is the most obvious. Okay, Anushka.
Yes, sir.
So what I do, that is known as normal pentane. Right, Rani? Normal pentane is means there is no branching. Okay, all the 5 carbon atom are just one after another, but someone may write it like this also. Okay, so don't get confused by the shape of the chain. You need to check that all carbon atom are one after another. That's it. Okay, and this is known as normal pentane, common name, and it is also written as N-pentane. Okay. So this is the one option which we can have, the most easiest option. And what other option we can draw? Abdullah and Rahim. Yeah, tell me. So try to make the chain short by removing one carbon atom. This is the chain of 4 carbon atom. But I can't stop here because I need to put 5 carbon atom. Chain is of 4 carbon atom. Total formula need to remain same. So where should I put the 5th carbon atom? Should I put it in the end? Is it the way to put? Yes or no? Is it going to give me a new thing? Pentane?
Yes, sir.
No, it is just same, because just what is there, all carbon are one after another. Just you, instead of putting my hand like this, I've done it like this. Okay, so this is not a new type of hand. Okay, so I will say, okay, this is my left hand. Okay, it may appear right to you because you are on the camera. Okay, so this is my left hand, and I have 2 left hand. Okay, this is the one left hand and this is another left hand. Okay, this is not the way. Okay, this is the same normal pentane. So where do I need to put this? So let's put it in the middle. Okay, this is the CH3. Okay, so this is called isopentane. Okay, and now what else we can do? We can have one more. Let's shorten the chain further. CH3, CH3, and now we need to put 2 carbon atom more and put them in the middle. Okay, don't put them at the end. If you put them in the end, then the chain will be considered as the longest chain. Okay, that will increase. That we have already taken. We have taken chain of 5 carbon atom. We have taken chain of 4 carbon atom, and now this is the chain of 3 carbon atoms. Okay, and suppose if you have 2 alkyl group, 2 methyl group hanging out of the second last carbon, this is known as neopentane. These are the common names. And these are the isomers, okay, of pentane. So first of all, tell me which is needed to be explained again. Any doubt? Or if you have some new isomer also, that you can also share with me. Okay, we will write and we will check. So first of all, I need to have an idea of how many types of pentanes are there, because the question is asking P, Q, and R. So question itself is telling 3 types of pentane, because the question is telling there are 3 types of pentane. They have same formula. Okay, and their names are assigned as P, Q, and R. But which one is P, which one is Q, and which one is R, that we don't know. Okay, we need to think as per the conditions given in the question. We need to discuss it. Okay, so you can see, so one is N-pentane, another is isopentane, and the third one is neopentane. Okay, is it clear? Any doubts in this, Laya?
No, sir.
Okay, good. Raneem, Abdullah, Anushka.
Yes, sir, clear.
Okay, so now I will start doing the chlorination, and instead of writing what I told you, do the rough work. Okay, in the rough you can apply the trick, and that trick will help you to know the answer without writing the complete answer. Okay, in the rough work you can do. Okay, but don't actually do it as a fair work, because you may not get the complete marks. Okay, so be careful about it, right? So what I will do here is I will just a second, the screen is gone, I think. I will now do the halogenation. Okay, and that will let me know how many isomers are obtained from each one of them. Okay, clear? Is it clear to all of you, my dear students?
Yes, sir.
Okay, so how many monochloro derivative the pentane will give? I will do it quickly by applying a short trick. So what I will do, instead of writing, I will put marks. Same type of marks means on the same type of carbon. Okay, this one and this carbon are same, and this carbon is different. Okay, so there are 5 carbon atom, but how many different type? How 5 carbon atom in the normal pentane total? But how many different carbon atoms are there? How many distinct new type of carbon atoms are there? Tell me.
Sir, three.
Yeah, how many are there, Anushka?
Three different carbon.
Three different. Yeah, very good. Because this one and this one are same. Because if you do the numbering from this side or that side, okay, that will be one first, or the carbon atom, the second and the last but one. Okay, the second last are same, and the middle carbon atom. So if I do the halogenation of this, I will get 3 different monochloro derivative. Okay. So without drawing the structure, I have already told you. Okay. So you can do it in rougher, but in fair, you need to show each and everything. Mono, chloro. Three different monochloro derivative. Okay. What if someone asks you to write their structures? You can write. Okay. Let me tell you one more way of writing. So this is the bond line structure, the one which we discussed just now. So this is the carbon atom, 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 and this one is the carbon atom. So you have 5 carbon atoms, but you don't put a single line. You, wherever the carbon atom is, you change the angle. Okay, this is also called zigzag formula. Okay, so that you can make out. So wherever the 2 lines are meeting, that is a carbon atom. And how many hydrogen are there? Suppose if there are two bonds, so there are 2 hydrogens. Okay, at this point. Okay. So where do I need to put the chlorine? Okay, we can put it on the first carbon atom, this one. Okay, this is a quick way of writing the bond line representation, in which I am not writing, not showing the carbon and hydrogen, but they are there. Just a quick way. So this is the structure of the 3 monochloro derivatives, and the IUPAC name are 1-chloropentane, 2-chloropentane, and 3-chloropentane. Someone may ask, can't we have 4-chloropentane? No, that is wrong, because if it is on the 4th carbon, you should do the numbering from the other side. That will give it, that will give that carbon atom as second position. Okay, second number. So that one will be the correct. So 3. So which isomer, which is N-pentane? Is it the P, or is it the Q, or is it the R? Which isomer is represented by which alphabet is representing the N-pentane?
Sir, Q.
Tell me. Yeah, it is Q. Okay, so N-pentane, normal pentane is the isomer Q. Is it clear? Okay.
Yes, sir.
Yeah. So now let's try this one, neopentane. This is the common name. What is the IUPAC name of neopentane? Tell me. Yeah, guys, come on. Raneem, Laya, quickly tell me. Abdullah. Now, what is the IUPAC name of neopentane? Neopentane is just a common name. Okay, IUPAC name of neopentane is, this is the longest chain of 3 carbon atoms of propane, and on propane you have 2 carbon atoms coming out from the middle, which are not the part of the main chain, because main chain need to be continuous. Okay, so 2,2-dimethyl propane. Okay, clear? That's the name of the IUPAC name of neopentane. So it has also 5 carbon atom because it is an isomer of pentane. So where do I put Cl? How many different places where I can put the Cl on neopentane? Let me write the bond line structure of neopentane. It is just a simple cross. So this is the carbon atom. You don't have to highlight the carbon atom by putting dots. Don't put the dots. I am telling you just so that you can make out where the carbon atom, these carbon atoms are. Okay. But you don't have to put. So we have 5 carbon atoms. You can see. Yeah, Anushka.
So we'll have the chlorine in 2 different positions, right? So we'll have
Yeah.
2.
So all these outer carbon are same. Do you agree?
Yes, sir.
Because this is just a cross if you tilt it like this, or okay. And all 4 methyl are actually connected to only 1 carbon atom. So all 4 methyl, either this one, this one, this one, this one, are same. So either you can put the Cl atom on any of the methyl. Okay. It may appear that it is the top or it is the lower, or which is the second one. Is this correct? Laya, Abdullah, tell me. Is this correct or incorrect?
Sir,
This is incorrect. Yeah, tell me.
So it's incorrect.
Yeah, incorrect. Because you can't put a chlorine in the middle because it doesn't have any hydrogen. Actually, this is a substitution reaction. You substitute hydrogen by chlorine. Because the middle carbon doesn't have any hydrogens, you can't substitute, you can't put chlorine there. And even if you put it, you can see that the carbon atom, this carbon atom has 5 bonds, and this is not possible. Okay. Clear?
Yes, sir.
And what about isopentane? So you need to do it quickly. Isopentane. Isopentane, how many? Isopentane, what is the IUPAC name? 2-methyl butane, and how many different? So neopentane is actually having only, this was incorrect, because you can't connect the Cl from the middle carbon because it doesn't have any hydrogen. Okay, that is, you need to remember. And the next thing is, yeah, so this neopentane is giving only 1 chloro derivative. Okay, so which one is neopentane? Which alphabet is representing the neopentane isomer? Is it the P? Is it the Q? Is it the R?
Sir, P.
Which one is neopentane? Q we have already decided.
Sir, P.
It is
P.
P. Yeah. Good. Okay. So P is neopentane, and that is the neopentane. Okay, this cross. Okay. And what about R? R is giving, so now we can, this is the R one. So without doing it, we can know, or but still we need to do, because this is a very, very important question. Okay, so actually you have a methyl. Okay, you have a CH3, you have a CH3. But my dear student, these two CH3 are same. This one and this one are same. Why they are same? Because they are connected to only one CH. Okay. So this is same. But this methyl is somewhat different from the two methyls which are, because those two methyl on the right hand side are connected to only same carbon, so they are same. You can change them. You can, the one which is upper, you can bring it down, on the with one who is down, bring it up. And that is not going to give you any new thing. Okay, but this carbon, this methyl is different, because you have a CH2 then CH. Okay, it is not same as that of the other two. Okay, and the next one is this one. Okay, this one is different, and there is one more carbon atom which we have not covered, this one. Okay, so but don't do this type of drawing and all in your CBSE paper. Okay, you will your marks will be deducted. Do it in the rough work. Okay, is it clear?
Yes, sir.
Do it in the rough work. Don't do it, show it as a main work. This is just a trick to make out how many different carbon atoms are available. Okay, now I can I have a picture, and that actually it saves a lot of time. And I, even for my all JEE students or advanced students, I suggest them, okay, do proceed it in the same way. Okay, just have an idea of what you are trying to do instead of start writing directly without having the idea. Okay, so that saves a lot of time. Okay, so now I can write the structures. So this one, you can write their IUPAC names also. Raneem and Abdullah, is it clear? Any doubt?
Sir,
Yeah.
so questions like these, when it come in the board exams, max, how many marks will it be?
Yeah, it will be around the middle 2-3 marks question, right?
Yes, sir.
Basic question, neither very big. Actually, they will give, we have covered all type of possibilities. Actually, they will give only a part of it, right?
Yes, sir.
They will not give the complete. So I need to remove hydrogen. But as of now, we need to discuss everything. Okay, this is the answer. Okay, so 4 different products. Is it clear, Raneem, Abdullah? Okay, now the next thing is, so this is how we have prepared from alkanes. So one more thing I need to say, speed of photohalogenation or rate of photohalogenation means how quickly it can be carried out. Actually, fluorination is very fast. So fluorination actually it occurs very fast, and it is actually because the fluorine is small atom, it gets bonded to the carbon atom very strongly and it gives a lot of heat. And that heat makes the reaction faster. So actually it is uncontrollable. Highly exothermic and uncontrollable. Means you can't control it. You can't stop it. Okay. And it is highly exothermic. And what happens is such reactions which goes out of control, you don't do them. Okay. And iodination is the other extreme. It is very slow. It doesn't get completed. Why? Because iodine is a very big atom, very large. It is from the fifth period, and it reacts well. It doesn't form bond. Okay. So mostly if someone says you do the photohalogenation, you either do take Cl2 or Br2. That's the main because you don't take fluorine. Okay, you don't take iodine also because that is very, very slow. So, but if someone say, okay, someone may ask that, oh, no, I prepare iodo methane for me. Okay. Okay. Prepare iodomethane for me. So we can say, okay, this is the one way. What does sign represent? Raneem and Abdullah, tell me. Laya, tell me.
So it means that the process is reversible.
Pardon? Yeah. It is reversible. And most of it, I put reversible means it can occur in both the directions, and I put the backward arrow very large, very long. Means may and is forward arrow very small. Means what? Means the reaction is actually toward the reactant symbol. So all the reactant are left as it is unreacted. Most of them are lying there. Very few amount of the products are forming. It's because it is very slow, it doesn't get completed. Is it clear? Laya, is it clear or not?
Yes, yes.
Okay. So, but if someone may ask you, okay, prepare iodomethane for me, how you are going to do? So you can write it as reversible, backward, reversible. You can't adopt this photohalogenation. Incomplete. So there is a way to do that. Okay. And the method is take either chloro compound, chloromethane or bromomethane, and do the substitution reaction. Or halogen exchange reaction. So you can't connect F and I directly. So connect Cl by taking, so Cl we can connect, that is not a problem, that we discussed. Okay, take methane Cl2H2, that will give you CH3Cl. And now use NaI, and that is halogen exchange reaction, NaI acetone. Actually, this is more soluble in acetone. Okay, and the I minus is going to come and join to the carbon atom, the Cl will come out. And why the reaction is happening? CH3I you will get, and the NaCl. NaCl is more ionic in nature, so less soluble, and that is actually beneficial for us. So if it is less soluble in acetone, it will form a precipitate and it will not react back. That's what we want. Okay, so that's how this halogen exchange reaction has taken place, and this reaction has a famous name that is called Finkelstein reaction. Finkelstein reactions. What is Finkelstein reaction? You can see over here what is Finkelstein reaction and why it is used. Tell me quickly. Yeah, what is Finkelstein reaction? It is used for the preparation of iodoalkanes. So, why iodoalkanes need to be prepared separately? Why can't we get them directly by photohalogenation? By taking I2 and sunlight. So for that, I have already told you that iodine is a very big atom and it doesn't react directly in the presence of sunlight. The reaction happens very less amount. Okay. So that's why you need to adopt some different method to get the iodoalkanes. So what you do, you take alkyl chlorides and alkyl bromides, and you take NaI and sodium iodide in the acetone, and this reaction is known as Finkelstein. Okay, and what is the logic? Why it happens? Here also someone may say that I is very less reactive and it will not react. Actually, the main role is played by the solvent acetone. So NaI is more soluble, so it will go and react with the alkyl halide, and the product form is less soluble. Okay, so that's how it is happening. Is it clear?
Yes, sir.
Very important reaction. Okay, very important, very basic, also very basic, but actually you need to remember it. Very important. Okay, the other thing is, so suppose someone may ask you, how will you prepare the fluorobenzene? So fluorobenzene is highly, again, very problematic, but we require a lot of fluoro compounds. Okay, for example, the Teflon is there. Teflon is used in many places. Okay, a lot of fluoro compound, fluoropolymers are very important. Okay, and in our refrigerant is the AC air conditioners, the compressor have that fluoro compounds as their coolant. Okay, that actually the gas which is running through the compressor of the AC or the fridge have that fluoro compounds. So fluoro compounds are very important, but how to get them? We can't get them directly by reacting with the alkane with fluorine, because the reaction will go out of control, and you can't get the what you want. You either your compound will break, or carbon bonds will break, or you have many fluorines connected. So how to get? Okay, so direct fluorination is not carried out. You can write it is highly exothermic, it's uncontrollable. So how you do it? So you do, the answer is, general answer is, use halogen exchange reaction. Okay, don't put fluorine directly. First put Cl or Br by photohalogenation, then exchange the Cl or chloride or bromide by fluoride. So what is the way to prepare fluoride? Alkyl fluorides. Okay, and I'm not talking about, my dear students, be very careful, I'm not yet discussed the preparation of aromatic halide, because they have entirely different reactions, entirely different mechanisms. Okay, so but don't worry about them, we will discuss them all. So how to prepare fluoroalkanes, preparation of fluorocompounds? The answer is very simple, by halogen, the general answer, halogen exchange reaction. Okay, by halogen exchange reaction. This is the general answer. Okay, but what type of halogen? Just now I did halogen exchange reaction. That was the replacement by iodide, and that was interesting reaction. And this is, if you want to put fluoride, this is Schwarz reaction. Okay, the Schwarz reaction, you take again take chloride or bromide. Okay, and you take AgF. Okay, okay, AgF if you take, then why I need to take it? So CH3F will come and AgCl or AgBr will form. Though other compounds are also given in NCRT, but AgF is best. So you can see COF2 is given, mercurous fluoride is given, SbF3 is given. This is the best. Why this is the best? Because, so this is Schwarz reaction, this is also halogen exchange reaction. This is because the AgCl and AgBr are insoluble and Ag fluoride is soluble. So if it is soluble, it can react quickly, and the products which are forming are insoluble, they will form a precipitate. Okay, they will settle at the bottom. So that's what we want. We don't want them to remain in the solution and react again, because that will spoil all our efforts. Okay, so what we want them to precipitate out as quickly as they form. Okay, so that we cannot have the backward reaction. Is it clear to all of you?
Yes, sir.
Okay, so yeah, just revise it, and I hope you understood well. I think we are running out of time, so let's have it on the next time. Read your NCRT, the basic introduction I already discussed with you. Okay, and do let me know if you have any doubt, any problem. Do keep it with you. Okay, do share it with me. Okay, but there are many things this I have not covered. Preparation of from alcohol. Okay, and this I have covered free radical halogenation. Okay, of alkane. You can read all these things. This I have not covered because this is aromatic is entirely different. I will cover it on the next class. This one, this one, this one, this one. Okay, because in NCRT, what is there? They have given randomly. Okay, but what I do is I start from alkane, then I will do preparation from alkene. So next time I'm going to discuss the alkene preparation. Okay, this alkene. Okay, I covered this. Okay, in halogenation, and you can have some of the questions you can do, but not all, because the alcohol this you can do preparation from alkanes you can do, but the basic you should cover completely. The basic, the type of classification of compounds you can do, you can read it completely, and let me know if any doubt. Don't keep it with you, I will help you out. Okay, these common name, IUPAC name. Okay, this all these things you can do it, right? And up to here you can do. This is the basic introduction, and the reactions I have covered. Photohalogenation, preparation of alcohol, we will, and alkenes we will do it on the next time. Okay, and aromatic, this aromatic means benzene. For benzene also we are going to do it on the next one. Is it clear to all of you?
Yes, sir.
Yes,
Okay.
sir.
Yeah, Raneem and Abdullah, any doubts in today's class?
Thank you, sir.
It's okay.
Okay, so let me end. Let me say goodbye. Bye bye. Take
Sir?
care. Good night. Yeah.
Sir, by when will we be able to finish this chapter?
Yeah, we will try to finish it as soon as possible. You can share what your concern is. Yeah, and you can also let me know the chapters which are coming in your examination. When are your examinations? We can quickly go through them also. Okay, don't worry about it. Right?
Yes, sir.
Okay, we can take a common chapter also. So